In today's lesson, we're going to look at what happens when atoms come together and join to form compounds. In order to do so, we have to define what an ion is. An ion is defined as a positively or negatively charged atom or molecule. So in order to examine ions, I want to take a look at lithium. Now lithium, based on its atomic mass and atomic number, has 3 protons, therefore 3 electrons, and 7 minus 3 is 4 neutrons. So let's draw a Bohr-Rutherford diagram of lithium. We'll start with the nucleus, 3 protons, 4 neutrons, and surrounding the nucleus, we'll draw in the electrons. In the first shell, we have 2 electrons, and in the second shell, we have 1 electron. Now, the first shell is full. It can only fit 2 electrons. The second shell, however, is not full. In fact, it's hardly full at all. So we have 1 electron, but we can fill it with a total of 8 electrons. Whenever an atom has an incomplete set of electrons in its outer shell, they tend to want to lose electrons or gain electrons depending on which task is easier. So for lithium, in order to have a full shell, it would have to gain 7 electrons. The second option is to have an empty shell. In order to have an empty shell, it would have to lose 1 electron. Now, losing 1 electron is easier than gaining 7. So that's what happens. In the case of lithium, lithium would tend to lose this electron here. And what results is a modified version of this atom that looks like this. So it has the exact same nucleus, 3 protons, 4 neutrons. This time, instead of having 3 electrons orbiting around the nucleus, it only has 2. But what makes this atom stable is now its outermost electron shell is full. It has 2 electrons, it's the first shell, so it only can contain 2. Therefore, it's stable. Since electrons are negatively charged, and we've lost a negative charge, then the overall resulting charge on this electron is going to be positive. So if you lose 1 electron, you become positive by a charge of +1. Whenever an atom or a molecule has gained or lost electrons, it is what we call an ion. So this is an ion of lithium. So we call it lithium ion. Understanding the formation of ions is really important in understanding the formation of ionic compounds. And ionic compounds form whenever a metal and a nonmetal react. We call these compounds ionic compounds, but they're really commonly referred to as salts. So one common salt would be table salt, salt that you sprinkle on your food for flavor. With ionic compounds, we always have a metal and a nonmetal. The metals tend to lose their electrons, and the nonmetals tend to gain the electrons. The metals losing electrons become positive ions, and the nonmetals gaining electrons, since they're gaining a negative charge, they become negative ions. Now these ions will stick together. They are attracted to each other and they form a bond. The type of bond that they form is called an ionic bond. So the definition of an ionic bond is a chemical bond that forms between oppositely charged ions. So let's take a look at our first ionic compound. This ionic compound is sodium chloride. and sodium chloride forms when sodium reacts with chlorine. In order to do so, I'm going to draw Bohr-Rutherford diagrams of sodium and chlorine. So the Bohr-Rutherford diagram of sodium looks like this. It has 11 protons, 12 neutrons in the nucleus, and then there are 11 electrons surrounding it. 2 in the first shell, 8 in the second shell, and 1 valence electron in the outermost shell. The next Bohr-Rutherford diagram that we're going to draw is chlorine. Chlorine contains 17 protons, 18 neutrons in the nucleus, and then 17 electrons surrounding the nucleus. 2 in the first shell, 8 in the second shell, and 7 valence electrons in its outermost shell. So sodium is a metal, and metals tend to lose electrons. In fact, it would be easier for sodium to lose this 1 electron than it would for sodium to gain 7 electrons in order to have a full shell. Now, chlorine has seven valence electrons. So what chlorine wants more than anything else is to fill its outer shell with 1 more electron. If it had just 1 more electron, it would have a full outer shell. So here we have a relationship in which one atom is desperately trying to remove an electron and one is desperately trying to receive an electron. So we can see a negotiation that would happen. And this negotiation would look like this. Sodium will give up its electron to chlorine. If sodium loses an electron, it's going to become a positively charged ion. It's lost 1 electron, so we'll have a charge of +1. And chlorine will have gained an electron. This electron came from sodium. And since it gained an electron, it will have an overall charge of -1. And we draw these ions inside square brackets. And the square brackets tell us that these are charged ions. So here we have a sodium ion and a chlorine ion. And they form an ionic compound called sodium chloride, or commonly known as table salt. So this positively charged sodium ion is actually attracted to the negatively charged chlorine ion, just like a north magnet would be attracted to a south magnet, and they stick together. And that's why they form a compound, because they're stuck together like a unit. We'll do a couple more examples. The second example that I want to do is sodium fluoride. So this happens when sodium reacts with fluorine. Now, instead of drawing Bohr-Rutherford diagrams, I'm going to draw Lewis dot diagrams. So a Lewis dot diagram of sodium looks like this, and a Lewis dot diagram of fluorine looks like this. Since fluorine is in group 7, it'll have 7 electrons. So sodium, being a metal, is desperately trying to lose an electron, and fluorine, being a nonmetal, is desperately trying to gain an electron. So again, we see this obvious relationship. Sodium will give its electron to fluorine, allowing it to complete its outer shell, and we're left with 2 ions. Here in square brackets, I've drawn a Lewis dot diagram for the ion sodium, which has a charge of +1. And next I'll draw a Lewis dot diagram of fluorine, which, since it gained this additional electron, has an overall charge of -1. This compound is an ionic compound, and it's called sodium fluoride. It too is a type of salt. This one is not used in kitchens. It's not table salt. This type of salt would be used inside toothpaste and is a good source of fluoride. So we'll do an additional example. This time we'll use an alkaline earth metal. We'll use magnesium instead of an alkali metal like we've used in the previous example. So magnesium has 2 valence electrons, and chlorine, being in group 7, has 7 valence electrons. So in the last example, the metal gave up one of its electrons. But this relationship doesn't really make sense for magnesium as it is right now, because it's only losing one of its 2 electrons. In order for it to complete this transaction, you would need a second chlorine atom. And magnesium is going to give its second electron to a second chlorine atom. So what we're left with is magnesium. Since it's lost 2 electrons, has an overall charge of +2. It's lost 2 negative charges, therefore is more positive and has a charge of +2. We're also left with 2 chlorine atoms. Each one has gained 1 electron and has a charge of -1. If you were to add up all the positive charges and negative charges, we have +2 and -1 and -1. You will see that they balance each other out. The number of positives equals the number of negatives. This is true for all ionic compounds. Now, since some are positively charged and some are negatively charged, they will be attracted to each other, and they form an ionic bond. This ionic compound is called magnesium chloride. Ionic compounds have very specific physical properties. They exist in solid arrangements called crystal lattice. So if you've seen salt as a crystal, you know its distinct shape. That is called a crystal lattice, and other compounds exist in that shape as well. In terms of solubility, ionic compounds are very soluble in water. When they do dissolve in water, what happens is the positively charged ion and the negatively charged ion are actually separated, and they can move past each other throughout the liquid. Ionic compounds are weak conductors of electricity when they are solids, but when you dissolve them in water, they become very good conductors of electricity.